Hello friends, welcome to Learner's Planet. Friends, this is our sixth session for real numbers. In the previous session, we discussed some problems, some theoretical problems as well as problems based on HCF of two numbers and how HCF of two numbers can be expressed in other forms, right? In this session, we'll be taking more problems, even we'll be taking multiple choice questions as well. So do revise the previous session before you come to this session. So let's begin the session now. Now let's try first question. Here we are given a number 2.131.131.113.1113 dot dot dot. So, and we are asked which type of number is this. See, after decimal the series is non-terminating, right? That we can see dot 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 are there, and it's not repeating as well, right? That means no particular set of number is being repeated continuously, right? So it cannot be a rational number. If it is not a rational number, it cannot be an integer because all the integers are whole numbers, right? And it is definitely a real number. Okay, so option D is incorrect. So definitely it is an irrational number because it is non-terminating, non-repeating decimal. Okay, let's take the next question. Now we have this question 1.2348 bar. Bar means what? The last number, that is the number on which the bar is there. It's being repeated for infinite number of times. That means this number is 1.2348888, right? So it's not an integer because integers have to be whole numbers. Now after decimal, definitely the number is non-terminating, but it is repeated, right? Because the digit 8 which is at the last or at after 4, it's continuously repeating, right? So definitely it is a rational number. So it's which type of rational number? Non-terminating but repeating, right? So it's a rational number. Okay, the previous example was of non-rational number or irrational number, and this example is of a rational number. Okay, it's not a natural number, and since it is a rational number, it is not an irrational number. I hope you are clear. Now in this question, HCF of this and this is 18. We have to find their LCM. So we know the formula that HCF into LCM of two numbers is product of the numbers, right? So product of two numbers is equal to their HCF into LCM. So we'll be using the same relation over here. Now product of the number is 306 into 1314. HCF is given to us as 18. So we can find out the LCM. So LCM will be equal to 306 into 1314 by 18, right? So if we calculate that, we will be getting 2222338, right? 22338. This. Okay. So this is how we can calculate the LCM of two numbers when their HCF is given. Okay. Now let's see this question. The product of two consecutive natural number is always an even number, odd number, prime number divisible by 3. Friends, whenever you are having this sort of problem, you just take two consecutive numbers, but do not or never take the initial number, that is 1, 2, 3, 4, something like that. You just take the some numbers in from like after 5, 6, something like that, right? So let's take 5 and 6. Okay. So these are the two consecutive numbers. If I multiplied them, I get 5 into 6 is 30, right? Similarly, I take one more example, so I just can reach a correct conclusion, maybe 7 into 8. Okay, or maybe 6 into 7. Okay, now it's an even number, that is true in all the cases, so it's correct. Odd number, it's not true. A prime number cannot be true because it's a product of two numbers, so it cannot be a prime. divisible by 3 is not always true. In this case, it's not divisible by 3, right? Because from 3 consecutive number, only one number is divisible by 3, right? So we have an even number as a correct choice. I hope you are clear. Now let's take this. 3.24636363 are right. Now definitely it's not non-terminating number. Decimals are given, so it's 3.24. But we can observe that 636363 is being repeated. So we can write it like this: 3.2463 bar. That means 63 is repeated for infinite number of times, right? So it's non-terminating but a repeating decimal, right? Non-terminating but repeating. So it's definitely a rational number. It's not an integer. It's definitely a real number, so it's not correct, and it's not irrational number. It's a rational number because after decimal, maybe it is not terminating, but the sequence is repeating. That is 63 is repeating, right? Now let's see this question. The real number 2, this is a real number, and we have to find out whether it is a terminating decimal or non-terminating decimal. So that how can we find out? By just seeing at the denominator. In the denominator, the prime factors are 2, 5, 3 and 7. That means we have the prime factors apart from 2 and 5 as well, right? So definitely it will be a non-terminating decimal. So we can say it will be a non-terminating decimal, right? Non-repeating we cannot say because it's a fraction, and if it is non-terminating and non-repeating, it will be an irrational number, right? An irrational number cannot be presented as p by q form, but this number is already there in p by q form, where p and q, both of them are integers and q is not equal to 0. So definitely it is a rational number, but it will be a non-terminating decimal because we have the prime factors of denominator as 2, 5, 3, 7, and if prime factors of denominator have other numbers apart from 2 and 5, then it will be a non-terminating decimal, right? I hope you are clear. Now we have this question: when a number is divided by 6, its remainder is always. See friends, remainder can never be greater than the divisor, right? So any number can be written as 6q, 6q plus 1, 6q plus 2, I just write 0 over here, 6q plus 3, 6q plus 4, 6q plus 5 form. So there are 6 forms if we divide any number by 6, right? Where q is any positive integer, right? According to Euclid's lemma, I have written this, right? Now what is happening over here? If we divide any number by 6, we'll be getting the remainder as 0, 1, 2, 3, 4 or 5, right? But the remainder cannot be more than 5, right? So greater than 6 is incorrect. Lies between 6 and 12, it's also incorrect. Greater or equal to 0 but less than 6, this is correct, right? And less than 0, the remainder cannot be negative. Okay, so this is the correct option. I hope you are clear. Now in this question, which of the following number has the terminating decimal representation? So friends, for terminating decimal representation, the denominator should have only 2's and 5's, right? So here in this case we don't have 2 and 5, that means we have a number other than 2 and 5, so it's not a terminating decimal, even it's not, only this number will have terminating decimal, that's 0.6, right? Because if we prime factorize the denominator, it should contain only 2 and 5 if it has to be a terminating decimal. Okay, now in this question, HCF of two numbers is this and their LCM is this. One of the numbers is this and the other number we have to find out. For the product of two numbers, is equal to their HCF into LCM, right? Now LCM is given as 1449, HCF is given as 23. One number is I assume to be A and the other is 161. So A is equal to 1449 into 23 by 161. Okay. So 23 sevens are 1661, 7 twos are 14, 0 and 7 sevens are 49. So it's 207. That means the other number is 207, right? Now friends, the next question is, according to the fundamental theorem of arithmetic, if P, where P is a prime number, divides B square and B is positive, then that means B square is divisible by P, right? So if B square is divisible by P, then according to the fundamental theorem of arithmetic, B should be divisible by P, or we can say P divides B also, right? So P divides B, right? For the other options, we cannot be so sure. B square divides P, we cannot be sure, because P divides B square, not B square divides P, right? So this is the only option that's correct, right? Now the next question is, if P and Q are co-prime, then dash is the only factor between P and Q. See, if P and Q are co-prime to each other, except number 1, no other factor is common between these two, right? Suppose we have an example 3 and 5, 5 and 9, 10 and 11, right? If the numbers are co-prime to each other, that in that case it's not necessary that the numbers individually should be prime, right? Even in this case, number 9 is not prime, but 5 and 9 are co-prime to each other. Similarly, 10, 11 are co-prime to each other. Okay, so the only common factor between these two is just 1, right? Now in this question, if A is divided by B, B is divisor, Q is quotient and R is remainder, such that R lies between 0 to B, then according to the Euclid's division lemma, yeah, any dividend, we know that dividend is equal to divisor into quotient plus remainder, right? So I just put up the value over here. Dividend is equal to A, divisor is equal to B, quotient is Q and remainder is R. That means A is equal to BQ plus R, right? So A is equal to BQ plus R. Okay. Now let's see this question. The number is in the form of 2m plus 3, where m is a whole number, b always. Friends, just do not get confused. Take any value of m and check whether it's an odd number, it's a perfect square, it's an even number, it's divisible by 3. I just take 2, 3 values, so I'll be able to reach the right conclusion. Suppose 2, 3 and 4, right? So I just put the value of m over here. So 2, when m is equal to 2, this expression will be 2 into 2 plus 3, that is 4 plus 3, 7, right? Now if m is equal to 3, 3 2s are 6 plus 3, 9. When m is equal to 4, then 4 2s are 8 plus 3, 11, right? So an odd number, yes, in each case we are getting odd number. Even number, no. Perfect square, no. In these two cases we are not getting perfect square. Divisible by 3, no, because only in this option we are getting that number is divisible by 3, right? So an odd number, it's always true. Okay, now friends, let's take some division, that is some word problems based on HCF and LCM, right? Now let's take up the first problem. The largest number which divides 245 and 1029, leaving remainder 5 in each case, right? That means what the question tries to say, that if a number, suppose x, we have a number x, right? If 245 is divided by x, we get 5 as remainder, right? That means what? So if we deduct 5 from 245, the number should be divisible by x, right? If 245 is divided by x, we get 5 as a remainder. That means if we deduct, see 5 is what? It's extra, right? So if we drop this extra from 245, the remaining part should be divisible by x. Yes. Similarly, the same case is with 1029. So if we deduct 5 from even 1029, the remaining number should be divisible by x, right? Now in this case we have to find out that particular x, right? So what I'll do, in fact, the number 245 minus 5 and 1029 minus 5, both of them are multiple of x, right? That means 240 and 1024. These are the multiple of x, right? Now we have to find out the largest number. That means we have to find out the largest number that is a factor of 240, that is factor of 1024, right? That means we have to find out HCF of these two data. Getting my point? So we have to calculate the HCF of 240 and 1024. Now we can choose any method, either prime factorization method or division method, to find out their HCF, right? I just take division method over here. So it's 1024 divided by 240, right? So it's 960. We got 64 as remainder. Further we would divide. So 64 threes are 192. So I get 48. Further I would divide. So it's 48. So I get 16. Further 48, 16 threes are 48, 0, right? So when the divisor was 16, we got the remainder as 0. That means 16 is HCF, right? So we got 16 as HCF. That means the largest number which divides 245 and 1029, leaving remainder 5 in each case. Now if you divide 245 by 16 and 1029 by 16, in both the cases you'll be getting the remainder as 5. Getting my point? The problem is really important, so you should be very much clear about it, and you should be knowing that this fact that if 245 is divided by x, we get 5 as remainder. That means 245 minus 5 will be definitely divisible by x, right? So let's take more problems. Now the largest number that divides 2053 and 967 and leaves a remainder of 5 and 7 respectively. The same concept we are using over here. If the number, suppose x is the number, let x be the number, right? So if 2053 is divided by x, we get 5 as remainder, right? That means 2053 minus 5 is divisible by x, right? And the second thing is, if 967 is divided by x, we get 7 as remainder. That means 967 minus 7 is divisible by x, right? Now we have to get the maximum value of x, right? So first of all, what are the factors of multiples of x? That is 2053 minus 5 and 967 minus 7, right? Now we have to get the maximum value of factor of these two numbers. Now 2053 minus 5 is 2048 and it is 960, right? Now we have to get the highest common factor of 2048 and 960. I hope you are getting me. So this can be done by prime factorization method and division method both as well, right? In the previous question I took the division method, so in this question I just take the prime factorization method, right? So it's 2048, it's actually 2 raised to 10 is 1024, so it's 2 raised to 11, right? And 960 is equal to 32 into 3, that is 96. 96 into 10, right? So it's 2 raised to 5 and plus 1 6 into 3 into 5, right? So these are the factors of 960 and these are the factors of 2048. So HCF will be, what number is common? That is 2. And what is the least power of 2? That is 6. So HCF is 6. 2 raised to 6. That means 64, right? So I hope you are clear. So if you divide 2053 by 64, you will be getting 5 as remainder, and if you divide 967 by 64, you will be getting 7 as remainder, right? So I hope you are clear. Now friends, let's try this question. The largest number that will divide 398, 436 and 542, leaving remainder 7, 11 and 15 respectively, right? So the concept is quite similar to the previous one. So let x be the number. So if this 398 is divided by x, 7 is the remainder. That means 398 minus 7 is multiple of x, right? Similarly, if 436 is divided by x, 11 is the remainder. That means 436 minus 11 is multiple of x, right? Similarly, 542 if divided by x, 15 is the remainder. So 542 minus 15, that is also divisible by x. So 398 minus 7 is what? 391. 436 minus 11 is what? 425. And 542 minus 15 is what? 520. Okay, so here we got the three numbers. Now we have to find out HCF of these three numbers, right? That is 391, 425 and 527. You got my point? The largest number that will divide these three numbers, leaving remainder the 7, 11 and 15 respectively. So we discarded or we eliminated the remainders. Now we are finding out the HCF of these three datas, right? Now how can we find out the HCF? See, we have two options. Either we go for prime factorization method or we can go by division method. So in division method, if we have to find out the HCF of three numbers, what we can do, we choose any two number, we find out their HCF, and from their HCF we take the other three number, right? I just explained the procedure over here. Now let's find out the HCF of 391 and 425. In the first step, 391 and 425, right? We will find out the HCF of these two, right? So I take the division method. So it's 25 plus 9, that is 34. Then it's 391. So 34 ones is 34. It's 5, 1. So it's 1. And then 34. Then we have 17. And 34, so it's 2, 0, right? So 17 is HCF of 391 and 425, right? HCF is 17. Now what we do in the next step, we'll find out the HCF of 17 and this 527, because in the first case we took 391 and 425. Now we will take 17 and 527. So now let's see what is the HCF of 17 and 527. So straightforward, what we can do, we divide 527 by 17. So 17 threes are 51. It's 1 7 for the 7 0. So in the very first step we are getting the remainder as 0. That means 17 is HCF of 17 and 527. In the previous case 17 was HCF of 391 and 425. So in all the cases 17 is the HCF of the three data, that is 391, 425 and 527, right? So we are looking for the unknown value, and that unknown value is nothing but 17. Okay, so answer is 17 over here, right? That means if you divide 398 by 17, you will be getting 7 as remainder. If you divide 436 by 17, you will be getting 11 as remainder. If you divide 542 by 17, you will be getting 15 as remainder. Okay, I hope you are clear. Now friends, we have this question. Two tankers contain 850 liters and 680 liters of petrol respectively. The maximum capacity of a tanker which can measure the petrol of either tanker in exact number of times. Exact number of times. That means the capacity of this tanker should be a factor of 850 as well as 680, right? And we have to find out the maximum capacity. That means what? We have to find out HCF of 850 and 680, right? Friends, you should be very much clear about where to find out HCF and where to find out LCM, right? Good number of students make mistake over here, right? In this case, what we are asked, we are looking for a container that can measure the quantity 850 as well as 680, right? And in exact number of times. No fractions are allowed. That is 3 containers is allowed, 3.5 containers are not at all allowed, right? So what we are looking for? We are looking for HCF of, first of all, a factor of 850 and 680. Now for the maximum capacity, we are looking for highest common factor, that is HCF, right? Now what will be the HCF of 850 and 680? We can go by prime factorization method as well as division method. So I just go by prime factorization method in this case. So 850 is equal to 2 into 5, that is 10, into 550 into 17, right? So it is 17 into 5, 85, 85 into 10 is 850. So these are the factors of 850. Similarly, 680 is 2 into 2, that is 4, and this is 17. So 17 fours are 68. So still we need 10. So it's 2 into 5, right? So it's 5 2s are 10, 170, and into 4 is 680. So we got the factors of 850 as well as 680. So now what will be the HCF? What is the common data? That is 2 over here. And what is the least power of 2? That's 1. Then we have 5 also common. So I take 5. Least power of 5 is also 1. Then we have 17 common as well, right? So it's 17 into 5 2s are 10. That means 170 will be HCF, right? That means the capacity of the container or the capacity of the tanker should be 170 liter. So we can measure 850 liters and 680 liters both as well, right? I hope you are clear now. Now this question, a sweet seller has 420 kaju burfis and 130 badam burfis. She wants to stack them in a way that each stack has the same number and they take up the least area of the tray, right? Now the number that can be placed in each stack for this purpose, right? That means she is arranging the burfis like this, right? Kaju burfi and badam burfi, something like this. Okay, now the burfi should take the least area of the tray, right? And every stack should have the same number. That means what we have to do, we have to find out the HCF, right? I just try to elaborate it. See, if we have to take the least area of the tray, that means we have to make minimum number of stakes, right? So if we wish to make a minimum number of stakes, that means what? In a single stake we have to arrange more burfis, right? So, and we want that each stack should have the same number of burfis. That means what? The same number of kaju barfi as well as the same number of badam barfi, right? That means what we have to do, we have to find out HCF of 420 and 130. That in that case only each stake will have the same number and maximum number. So if the maximum numbers of burfis are there in a single stake, then only the minimum area of the tray will be covered up. Getting my point? So what we are doing over here, it's 420 and 130. We are finding their HCF, right? So you can go either way, by division method or by prime factorization method. I take division method. It's 390, then it's 30, it's 130. So 34s are 120. I get 10 as remainder. Divided 30 divided by 10, 3, 30, 0 as remainder. That means 10 is the HCF, right? So in each stake we should place 10 burfis. That means 10 burfis like this. Then on the other stake 10 burfis, something like this. Okay, so they will take the minimum area of the tray, right? And each stake will have the same number. Okay. Our friends will be taking more problems in the next session. Do revise this session and the previous ones as well. Bye bye.